important part in your whole physics classes. If you don't know this vector addition informations, that means your learning that you are doing in any other class in physics does not make any sense. That means you definitely not going to apply the things that you're going to learn. Simple example, you guys know that electric field, electric force that we talk in your 156 class is belong to mostly about the vector part that we discuss in 116 class. And then when we come to the magnetism part, again we're going to talk about magnetic field, magnetic force. Now those things you are not able to work on those vectors unless you do not know how to do this part. Okay, so it is very important part, and I am going to only discuss vector addition by using analytical method or the component method, because this is the most powerful method that research say in us that the student should follow. Right? There are many other methods, cosine rule, sine rule, and different methods that people teach in you how to add the vectors, but that's not powerful. This is the powerful method of learning vector addition, and also it work for any kind of vector without any limitation. Because of that, all the textbook following this method, because that's the most powerful method that students should know beginning of the your physics classes. Then you can explore yourself to use the other methods, but that's extra work if you want to learn. Otherwise, this method is enough for you to work on the vectors. Okay. So now vectors, you know that it is just a magnitude and the directional information, physical quantity. We need to care about the direction at the same time as the magnitude. So because of that, we have some rules that we need to consider when you add those vectors, right? So first thing is everybody know that we have the coordinate system, right? So we have the directional informations are important. Because of that, you need to really see that what is your coordinate system is. So let's say I have my coordinate system like this, right? So now in this direction, I have x direction, and this direction I have y direction. Those both are positive. When you go to this direction, that is your negative x, and this is your negative y direction, right? So now you have quadrant 1 in here, you have second quadrant, you have third one, and you have fourth one. So any vector that we are working will be belong to one of these four quadrant. So that means you need to identify the vector that you are going to add are in which quadrant first. Okay, so we'll say I have a vector in my first quadrant, somebody given to you. There is a vector, we'll say it is E1 vector, electric field or something, E1 vector, right? So now the person that say in the electric field should give you the direction, because E1 is just the magnitude. So we'll say this person say in the direction here is theta 1. So you have E1 vector inside your first quadrant and theta 1 is given. So now what you know first quadrant means, this theta 1 value should be in between 0 and 90 degrees. Then that will be within the first quadrant, right? So now this vector that I have it on the first quadrant will be able to project into your x-axis and to your y-axis. This projection, we call it as the component, right? So now what is the projection means? That means you have this vector, I'm going to use the dotted line in here. This vector I can project into this direction. That means basically if you complete this parallelogram, this is the parallelogram, but if you complete this parallelogram, you have this two side length. Parallelogram has the opposite sides are equal, right? So now these two sides are labeled we call it as the projection of E1 vector, or that is the component of E1 vector. So now this is the E1 x component, and this is the E1 y component. Okay, so now writing E1 x and E1 y is, we call it as writing component, right? So now since my E1 x and E1 y are in positive x and positive y direction, those two are positive numbers. That means here my E1 x is positive and E1 y also positive. That means if you have a vector in first quadrant, that vector has the component x and y in positive values. Okay, I'm still writing magnitude. I did not write any direction yet. Okay, direction label in theta 1. So now E1x, how I find adjacent of E1 is, you see that when you have the adjacent, that will be basically your E1x vector. Opposite will be the E1y vector. Why? The one that I have it in here as E1y will be exactly same length on the parallelogram in the opposite side. Okay, so now E1x will be adjacent. How do you find the adjacent? You know that you can always go back and think about the trigonometry. If you know hypotenuse, you need to find the adjacent. Adjacent means the closer to your angle length, and other one is the opposite, right? So everybody know this thing. So this is the first time that you can definitely draw the diagram yourself and think that how you're going to find it out. So I'm going to draw it little here. I have theta 1 here. So now I know that I'm working with the distance. So this hypotenuse is E1. I need to find this distance. That is what I call it as E1x, right? This is what I call it as E1y. So does everybody know that E1x is the adjacent of this rectangle, right? And E1y is the opposite. So now after you know that adjacent is coming from cosine of theta 1 is equal to the adjacent over hypotenuse, right? That means E1x divided by the E1, right? And then similarly, your sine of theta 1 is equal to E1 y over E1. So after you know this, you don't want to write this all the time when you do the vectors. Only thing, after you realize, do this one cross multiplication, do the cross multiplication here, then you know that this E1 x equal hypotenuse times cosine of theta 1, and E1y is equal hypotenuse of sine of theta 1. So now this trigonometry is the first step that it will come, but you don't actually need that information after you realize that your adjacent, identify the adjacent first. Adjacent will be always hypotenuse times the cosine of that angle, and opposite will be always hypotenuse times the sine of that angle, right? So now after you know that, you can go and write it in here. This will be E1 cosine of theta 1, and this is E2, also E1. Hold on a second. E1 sine of theta 1. So both are positive. That is first quadrant, right? So now you can walk through other quadrant. We'll say I'm not going to take time to the other quadrant. You can take a look. We'll say one vector in the second quadrant, then third and fourth, you can work yourself. We'll say I have a vector in the second quadrant, E2, right? So as soon as I draw the vector, I need to complete my parallelogram. That's for understanding. So now this length I have here is E2 and X. And this length I have here, opposite of that one will be E2 Y, right? And let's say angle is given this one as theta 2. Okay, so now you go to your that quadrant. Now it's very important that E2 X is a negative number. Everybody understand why? Because it is in negative x-axis. E2y is still a positive number, right? So now according to the angle, Jason will be E2x right now. Because of that, this will be E2 cosine of theta 2, and this will be E2 sine of theta 2. Okay, so x is negative and y is positive. If you go to the one vector in third quadrant, then both are negative. If you go to the fourth quadrant, then y is negative, x is positive. So you're going to let's do one more example, although time takes. We'll say I have third quadrant, this vector, say E3. Okay, so now E3 parallelogram will be this one, right? So that means the vector projection that I have in y direction is E3y, x direction is this one, E3x. So now you see that E3x is a negative, but E3y also negative. We'll say angle given is this theta 3. So now you need to identify, just after seeing your angle, what is E3y is. Now closer to the angle, you have the adjacent. That means E3y is the adjacent in this case. So that means this will be E3 times the sine of theta 3. The other one will be always the sine. Okay. So now this is the way that you need to find the component of all the vectors, right? So after you write those things into your problem, then you know how to add it. Now we'll say I have E1, E2, E3, three vectors. I need to add them. How do I add them? So now add E1 vector, E2 vector, and E3 vectors, right? So now how to add these three vectors? I already have all the components written down. Then I need to just write what will be my whole EX. So after you calculate your net resultant, we say net E, the one that I need to find. Now E is the net one, right? So now you're going to draw a diagram, or you can think in your head. It is always better that you draw at least a cartoon of the diagram. That what you're going to do. This is your E vector X. That means this is what the result, and that I'm planning to find out, that I label it as actually E in your sample. Label it as E. That's the resultant vector. And this is the resultant vector Y component, right? So this is the angle that I wanted to find it out later. That will be your resultant angle. Okay. Okay. So now if I need to add the vectors, we have to do magnitude and direction separately. Okay, so in your class, we never talk about I, J, K unit vectors. Don't use them for your class unless you know actually how to work with them. Okay, don't check the YouTube video. They use the IJK. I'm going to use the IJK and use my numbers. That's not going to work. You need to use the things that you learn. Okay, not the others are using. That is for the calculus based class. Okay. Okay, so now we have E, right? So before finding E, I need to Now do this backward way. That means I need the X projection and Y projection first, and then I will be able to calculate the E. So EX is the resultant vector X component. So that will be equal to the your first vector X component plus second vector X component plus third vector X component. If you have more, you just add all the vectors X component to that. Okay, so we'll say you get some number in there, and then EY will be you add in all the component with that all the negatives and positive you have. You need to write 1y E2y plus E3y plus dot dot. Right? If you have more vectors, you're going to keep adding those vectors. Right? Now you're going to find this number and find this number. Right? So now after you find those numbers, now we can use the parallelogram that you have it in there to identify how to find the result and then how to find the angle. So now the parallelogram, I did it in here. EX is positive and EY is positive by assuming these two are positive numbers. If one is negative, then you need to draw your vector within that quadrant. Okay, so I thought that this vector resultant is in my first quadrant. That's why I have this diagram. If your vector is going to be second quadrant, after you calculate those, if y is negative, that means you need to go to the second quadrant. Then your parallelogram you need to draw this way. Okay, then your vector is stay in this way. If that happens, if your second, the y component is negative, if your x and y both are negative, your vector will be in third quadrant. Okay, so you need to analyze accordingly by using the numbers you calculated in here. Okay, now in simply my case, since I don't have the numbers, I approximate these two vectors after I add it, both going to be positive, and because of that, I will go to the first quadrant. Okay, but after calculate the numbers, you will be able to see it. So now after I find the EX and EY, by watching this diagram, you know that this opposite length also EY and this length also EX. That's what the parallelogram means. Opposite sides are equal, right? So now what do you know by using this one? Now you can use Pythagorean theorem, right? Pythagorean theorem. So now by using this theorem that you learn in elementary school, you will be able to find the hypotenuse if you know adjacent and opposite. So now I know adjacent, I know the opposite, then I will be able to find the hypotenuse. Now hypotenuse is the one that I call it as E in the diagram. That will be equal to E1 squared plus E EX squared plus EY squared and square root of that. This will give you what? Just give you the magnitude. This is just the magnitude. It did not give you any direction, right? So now direction I label as theta. So now you see that you can write tangent of theta will be opposite over adjacent. That means EY over EX, right? So from this, you can find, from this you will be able to find theta angles. That will be tangent inverse EY over EX. Okay, so now this is the direction, but there is very important thing in the direction. So you need to express with respect to positive x axis always. Space always. That's very important. So now in my case, I label my theta angle in positive x-axis. You see that? Theta angle I measured with respect to positive x-axis. That means this will be directly my direction of the resultant vector. But what I mean by here, if you get your EY negative, that means you are working, your EX negative, that means you are working in your second quadrant. If your EX is negative, EY is positive, after you complete your parallelogram, that's why this cartoon is important. Your resultant will be somewhere here, right? Then when you take your angle, whichever that you are thinking, if you measure this angle, then you have tangent theta equal EY over EX, but you are measuring this angle, right? But what I need is with respect to your positive axis, that means this is the positive axis, you need to find by adding or subtracting according to what you get, you need to find this angle. Okay, that is the rule for the answer with the positive x. That means you know that it is 180 minus theta. If it is on the second quadrant, if it is on the third quadrant, you need to probably add that angle into 180 according to the case. Okay, so this is how you're going to add the vectors. Make sure that you follow this. Very important. And do a couple of examples and see that you can add the vectors by using this component method. So now in addition to that, I hope after you watch this video, you understand those directions are important concept, right? If you don't have direction of those vectors, whatever you are doing is meaningless, right? So that means whenever you use electric field, electric force, magnetic field, magnetic force, Newton's second law, free body diagram is very important concept. Free body diagram is basically a force diagram that act on the center of the system at that time, center of the system or the object that you are going to use. You draw the diagram, then you can see the vectors as I have it in this coordinate system, and then follow whatever you are doing to find the EX component, Y component, and use the Pythagorean theorem. Pythagorean theorem, I think I missed the N here, and theorem, and then calculate the magnitude and find the direction by using tangent, then write it with respect to positive x-axis, right? So it's very, very important that you follow it. So important thing here, without drawing the vector, that's what I told it as free body diagram. So without drawing this, vector cartoon, your result, the calculation you are doing is wrong. Everything is wrong. Very important. Okay, so draw it and do it. Right, you remember that one of the example in your, I think 102 homework, that you have the charge in here. I don't remember the question, but we had the charge in there, and then it's asking you to take the your point of interest P in here. Then you have the charge in here. So I think this one is a positive charge as I remember. This one is a negative charge as I remember. But now you have length A and B. I don't know which one is A, which one is B, but you have A and B. Now you need to identify what are the source charges. Source charges is lowercase q and uppercase q. And then P is your point of interest, right? So P is the point of interest. That is where you're going to draw your free body diagram, right? So now, since this one is a positive charge will create an electric field outward direction. We know that it will do around that charge, but we don't care about the other places. What we care is here. you even don't want to draw this. What you need to do is, here you have the electric field created by lowercase q in this direction, right? So now negative q that you have on the top, uppercase q, will create a electric field. Try to find the different pin, but it's not visible. So now this q also will create an electric field towards that, right? We already know these things. You don't want to draw it, but I'm going to show you what will happen. So this is electric fields. So now what my point of interest does is, it has the electric field this way. This is the EQ is, right? So now I have two vectors, but these two vectors, I am not able to use the Pythagorean theorem. Why? Pythagorean theorem only work when you have two vectors perpendicular to each other. You see that? What I did it in here, I make all the vectors into the perpendicular direction. That's what the component method basically doing. So that will convert all the vectors. You have it on the problem to two perpendicular vectors. If you have two perpendicular vectors, then you will be able to use the Pythagorean theorem. Otherwise, you are not able to do it in here. This one you all need to try the x component and y component first. After that, you can use the Pythagorean theorem to solve it, right? So why pre-body diagram is important? So this direction is coming from information about the electric field. So if you get the wrong direction, what happens? You think that somebody is thinking this direction, I got the wrong. Then your direction is here. You are calculating something totally wrong by taking wrong direction, right? If somebody think EQ is this way, that means you are doing totally different problem than what the problem is asking. Because of that, follow those things very carefully, because direction is one of the most important part when you work in the vectors. If you do not draw this diagram, that means your calculation makes no sense. Okay. So I think that's enough. If you have any question, please join the office hours. This is your learning program that you need to learn and apply. It is okay to join and ask questions. Okay, so that's why I am here.